I need to, I'll share my screen. Okay. So can you see the notes up there?
Yep.
Right, okay. So you got the notes?
Yep. Yep.
All right, let's go. So, as I said, today we're going to talk about codes and standards, introduction to the NCC and the AS1668 codes, which are probably the most important documents for you to be aware of. You're going to use them almost every day, at least every week anyway. You're going to be looking at them. And probably AS1668 Part 2, you're all familiar with that already. The other ones, maybe not so much, but I really want to stress the importance of those today. The current version of the NCC is the 2019 edition. It was supposed to be updated last year, but they had some problems getting it done. Was delayed. It's going to be released, the 2022 is going to be released on the 1st of May 2023, this year. So the 2019 will be superseded, but there'll be a transition period. So you'll still be able to use 2019 for a certain time. That'll be spelled out when 2023 version comes out. So because some projects are just starting now, so they're going to be subject to the 2019 version, but it'll probably be relevant for about 12 months, I'd say, and then 2023 will take over. I don't know what the changes are going to be. You can look up online the changes, but I haven't done that yet, but we'll wait and see what comes out. No doubt the energy efficiency will be updated again, and there'll be some other changes. The NCC makes reference to Australian standards where applicable, and for example, AS1668. So I've said here, Part A4 of NCC has the reference documents. So I'll get onto that. I'll show you that on page 23. Okay, so can you see that? NCC reference documents?
Yep.
Yeah, all right. And you can see here under A4.0 reference documents, there's a link here to Schedule 4. So these words in blue, you can click on those and it'll take you there. So I'll click on that, and there are the reference documents. So you can see that there's Australian standards over here. And as I said, AS1668 is down here, Part 1, Part 2, Part 4. So if those standards are referenced in the NCC, then it's mandatory that you comply with them. Okay, there's no option there. You must comply with those codes. If there's a standard that is not referenced in the NCC, it may not be mandatory to refer to that. But there are other things that may refer to it. There might be local regulations or other requirements that refer to standards that aren't in the NCC. You know what I mean? So you still may have to use it. And if it's not referenced anywhere, then the fact that there's a standard, an Australian standard, means that that's accepted best practice, and it's advisable to use that standard, unless you've got a different way of doing it. But so we'll go back again. So yeah, so that's what I've said there. It may not be mandatory if it's not referenced in the NCC, but it's recognised as good practice. So the next part of the NCC that's important for you to be aware of is part A6, which talks about building classifications. It describes the classifications of buildings based on the purpose for which they are designed, constructed, or adapted for use. The classification is important as it's used throughout the NCC to define requirements for that particular classification. Are you familiar with this? Just give me a shake of the head or not. If you've come across this before. I know I've talked to the MEPAC guys about this before. Kaushik, are you familiar with this?
Yeah, the building classifications, the office tenancy, residential apartments, those different kind of classification of the building. Yeah.
Yeah, so that's good. That's important to know. Good morning, Stephen.
Good morning. Sorry, I'm late.
Thanks for joining us. You're right. No, we just got started because everyone's got time constraints, so we just got into it. We're just working through the notes and referring to the relevant documents as we go along. I'm not sure. It depends on the discussion how far. I've got to get through this today because we've got another session next week. So it might be a bit quick, but by all means, ask questions at any time. You can interrupt me and ask a question if you want to as we go through. So, example, we're talking about building classifications. Class 2 is a residential building, Class 5 is an office, Class 6 is a shop. And I'll just go to the NCC and we'll have a look quickly through those. So page 30. Can you see what's up on the screen, Stephen?
Yeah, I can.
Yep, okay. Okay, building classification. Now, in the NCC, we're dealing with basically Class 2 to 9 buildings. And this is volume 1. That's the most relevant to what we do. Class 1 is a house. So, look, we do houses. We do air conditioning for houses, so that may be relevant. So, well, it will be relevant if you're doing a house, but generally, it's Class 2 to 9. Class 2 is really residential building. Class 3 is a residential building providing long-term or transient accommodation, for instance, a boarding house or a hotel, etc. Class 4 is a dwelling in a Class 5, 6, 7, 8 or 9. Sometimes that comes up. Class 5 is a very common one. It's an office building. Class 6 is basically a shop type environment. So there's a few different things there, but basically it comes under shops and shopping centres and so on. In Class 9, 9A is a healthcare building, a hospital, for instance. Class 9B is an assembly building. So all those classifications, you need to be aware of it, but if you've got a job that comes up, a new project, one of the first things you would do, if it's not given to you, is to go to the BCA and determine what class of building it is, because that's going to set out the requirements for various aspects that we'll talk about as we go through. Okay, so part C3, I've just picked bits out of this that you're going to need to refer to on a fairly regular basis. There's a lot in the NCC, there's hundreds of pages, and you can't be expected to know all that, but you need to know the relevant bits to look at. Part C3, protection of openings, is really talking about fire dampers and that sort of thing. So we can have a quick look at that. Page 78. Protection of openings in the external walls. I don't want to go through this because there's too much, but what I suggest is, put it on your list of things to have a look at, have a read through, get familiar with it, so you know what's in there, basically. So, for instance, this first one, if the distance between the opening and the fire source feature to which it is exposed is less than 3 metres from a side or rear boundary, or 6 metres from a far boundary of road, etc., then it needs to be protected with wall wetting sprinklers, etc. Just have a look through. There are situations where you might have a couple of buildings next to each other, or you might have a building that's close to a boundary, and you want to put an outside air intake into the building, and it happens to be, let's say, within less than 3 metres from a boundary. Then you would have to put a fire damper in. If it was 6 metres from a boundary, you may not need to. Things like that. Just be aware of reading through this to see what you have to do. And it takes a little bit of time to understand what they're asking for, but again, as I said, this is an awareness session. We haven't got time to go through it in detail. Smoke hazard management is another important section, and this is where we're starting to talk about smoke control. It sets out requirements for smoke control in the event of a fire in the building. Again, classifications are very important here, building classifications. Different requirements apply to different building classifications and are listed in tables E22A and 22B. I've made a little note on my notes here. Note the ands and the ors. When you go through the NCC, it'll give you options that'll say or and we'll see that in a second. I just want to mention to you, you'll see requirements depend on the effective height of a building. That is, whether it's more than or not more than 25 metres high. I don't know whether you're familiar with effective height, but this is important. The effective height is basically the height difference between the building egress or escape level. So example, the street level where you come out of the building to escape from the building. It's usually street level, and the highest occupied floor level. So if it's a 15-storey building, for instance, the height is the difference from the street to the floor level of the 15th floor. If there's a plant room above that, that's not usually considered because there's no one in there. Normally, there might be someone in there doing service, but you haven't got a regular occupation. So it's to the top floor level. Effective height is important, and I'll show you why in a second. So we go to smoke hazard management, page 191. Okay, I'll just scroll down to these tables. You might like to have a read through all that preamble. Firstly, it talks about fire isolated exits. So I guess you guys have some awareness of stair pressurisation. Okay, this talks about where you need to provide stair pressurisation. Hello, Andrew. Welcome.
Hello.
We got started at 10, so we're moving through the notes and referring to the NCC at the moment.
Yep.
So just quickly go through this. Fire isolated exits. A fire isolated stairway, including any associated fire isolated passageway or fire isolated ramp, serving any story above an effective height of 25 metres. So straight away, there it is, the effective height. More than 2 below ground stories, etc., etc. And see it's saying or. So any of these situations, but here we've got an and fire isolated passageway or fire isolated ramp with a length of travel more than 60 metres to a road or open space must be provided with. Okay, I'm just stressing that a little bit. An automatic air pressurisation system in accordance with AS1668 Part 1, or open access ramps or balconies in accordance with D 2.5. So that means you've got 2 options. If a building is within A and B, it must either have stair pressurisation or an air pressurisation system or open access ramps. Open access ramps or balconies means that basically you'd have a stair outside the building or open to the outside air. And we have done this in the past at times. As an option, some architects are aware of the options. Well, you need to make them aware of those options anyway. They might choose to put a stair outside the building to avoid the requirement of stair pressurisation. It's pretty rare. They don't like doing it, but sometimes it might fit their design. Okay. The next part, buildings more than 25 metres in effective height. So it goes through the various building classifications and what the requirements are. So for class 2 and 3, it must be provided with an automatic smoke detection and alarm system complying with specification E22A. So that means in mechanical services, HVAC, you're off the hook in this case, okay? You don't have to do anything except you still need stair pressurisation because that's it's more than 25 metres high. Is that clear? In other words, you don't need to provide a smoke exhaust system in this case. Class 5, 6, 7B, 8 or 9B buildings must be provided with a zone pressurisation system. Okay? Now that's, again, referred to in AS1668 Part 1. So this is telling you what is required, but you have to go to AS1668 Part 1 to determine the details because that standard goes in all the details of how you design that system, how you design it, how it's supposed to operate and be commissioned. And so on. Class 9A, hospital healthcare buildings. Now, buildings not more than 25 metres in effective height. The rules change a bit here. For a start, you don't need stair pressurisation. Okay. However, one of the other documents that you need to refer to when you start a project is the fire engineering report. Just about every project these days has a fire engineering report, and they might change things. They might say, well, the NCC and AS1668 Part 1 says that we have to have a pressurisation system, smoke control. However, the fire engineer might come up with a way to delete that or to take it out and provide something else to achieve the same objective. You know, I'm not saying that they will, but they just might. They might do anything. Or they might say, well, NCC doesn't require this. However, because of the design of the building or because we're trying to get some concessions in other areas, we want you to put in stair pressurisation. We want you to put in smoke exhaust. So you need to read it, understand what they're asking for. I looked at a project yesterday. I was just reviewing some drawings, which the fire engineering report did not even have a section for mechanical services. It was totally nothing required as far as the NCC was required. And I double checked that and it was correct. So just you've got to read those documents and understand what the requirements are. So look, we're not going to go through this in detail, but you can see there's a lot there and you need to refer to that for your projects and understand what the requirements are. Table E22B, specific provisions. Class 6 buildings. Class 6 is a shopping centre or a shop in a fire compartment more than 2,000 square metres. So this is like a Woolworths store or a Kmart, Coles, any of those big box stores have some special requirements. So once again, if it's more than 2,000 square metres, the fire compartment must be provided with an automatic smoke exhaust system complying with specification E22B of the NCC, or automatic smoke and heat vents, or so on and so on. So you've got some options there. And yeah, you might be able to, some cases, you might be able to say to the fire protection company, if you provide a smoke alarm system, a smoke detection alarm system, we may not have to provide a smoke exhaust system. Sometimes there's the option there. And it's normal that they're going to provide smoke detection alarms anyway, so you may not have to provide smoke exhaust. But the FER might say, well, for this building, you have to do it. So what I'm trying to do is give you some awareness of the interconnection between these documents and the codes as to what you need to do on a project. Okay. Let's see. Now we're up to any questions so far before I ramble on. I hope I'm not. It's a bit of a droll subject, but it's so important that we need to go through it. All good? Just a nod of the head will do. Righto. So part 4, light and ventilation. There was a typing error here. It should be page 267. We'll have a quick look at that. Okay. Excuse me. So light and ventilation. The first part of this talks about lighting, whether it's by natural light or by artificial light. And then part 4.5, ventilation of rooms. So this is saying that a habitable room, that's a defined term, office, shop, factory, etc., must have either natural ventilation or, again the or, mechanical ventilation in accordance with AS1668 part 2. It's got to have one or the other. Generally, it will be mechanical ventilation, but sometimes natural ventilation is applicable. So there's some requirements here for natural ventilation. For instance, if it's an apartment building with openings directly to outside, you need 5% of the floor area of the room to be ventilated, has to be openable. So if you've got a door that goes out to a balcony off a living room, if that's 5% of the floor area, you can use natural ventilation. Likewise for bathrooms, if they've got windows to the outside. If you've got a bedroom that doesn't have a window, for instance, you might be able to borrow ventilation from an adjoining room. But then these numbers have to increase to allow enough air to come in to provide ventilation for that room. So you can read through that. For instance, 47B in a class 5, 6, 7, 8, the window, opening door, or other device has a ventilating area of not less than 10% of the floor area of the room to be ventilated, measured not more than 3.6 metres above the floor. This doesn't happen very often, but there is the option there that if you want to use natural ventilation and it complies with the NCC, then you can go that way. Just be aware from an engineering point of view and good practice point of view that even though natural ventilation may be permissible under the NCC or AS1668 Part 4, it may not be practical. Because if you've got an office building that's got windows that can be opened, you have to make the decision, will they be opened? Is it really sensible to open the windows? Because if you're working in an office, you probably don't want the noise from outside or the wind or, distractions from outside the building and drafts and so on. So it's not always practical. It might be okay for a standalone shop that's open to the street where the doors are probably open anyway. So maybe you can use natural ventilation in that case if you've got 5% of the floor area. That makes sense?
I have a question for Peter. What if we don't have enough enough opening on the window? Can we go for a mixed ventilation, mechanical and natural?
You can, yes.
Yeah. Is there any
that's-
clause in NCC that we need to look at for the mixed mode of ventilation?
Yeah, you can. That's a little bit tricky to work out. I think AS1668 Part 4 would give you some guide there. What sort of building is it?
It's a community center and open space for the functions. So I have almost 50% opening in the window. So as of now, I
Yeah.
consider 50% from the windows and other 50% I worked out based on the capacity and the pressure requirements.
Yeah.
Yeah.
Yeah,
See,
look, I can't give you a definite answer on that. You'd have to have a look through AS1668 Part 4.
Part 4, yeah.
It's more of an engineered solution.
Mhm.
I know, we've done it in car parks, and you can allow a certain distance in from the perimeter and call that natural ventilation,
Mhm.
and mechanically ventilate. When you're inside the building.
Inside, yeah.
Again, you have to use a bit of judgment as well, I think, to determine or decide whether that's really a feasible way to do it. If they intend to open windows when they're having functions, then yes. I think you'd need to talk to the client and be sure of how they're going to operate the place.
Happy. Yeah, client's happy because looking at the capacity of that place, if we allow 200 people's fresh air, then heat load goes very high, so the cost goes up. So we want to keep the outside air down and use the windows.
Yeah, I think it's a reasonable approach. Just the client needs to be aware that if it's a hot day, if it's a hot day or a cold day, and they want to close the windows and they get a full house, then they may not be complying with AS1668 Part 2 or the NCC. So you've got to make use a bit of judgment, common sense, I suppose, that if you're satisfied that it's feasible and can operate that way, I think you can do that. But just be careful that you're covering the requirements in all modes. And if they do have a function on a hot day and they've got a full house, have they got enough ventilation?
Yeah, they have to keep the windows open.
They want to shut the windows on a hot day or a cold day or a windy day. Does it work? I think you just have to ask yourself those questions, and if you're satisfied, then you can do it.
Yeah.
Okay.
Yeah. Thanks.
All right. So now just to finish off here in this part F4, this also refers to car parks and kitchen exhaust, and again refers you to AS1668 Part 2 or Part 4 if you want to use natural ventilation for a car park. Sometimes, if the car park's above ground, that can work, and it certainly saves capital and running costs. Kitchen exhaust ventilation, again, there's reference to 1668 Part 1 and Part 2. Mechanical ventilation and fire safety. All right, back to the notes. Excuse me. Now, Part J5 of the NCC talks about energy efficiency. This is one that you probably refer to several times a week, maybe every day, maybe not, but quite often anyway. It sets out the requirements for energy efficiency. As I said, you'll refer to it constantly. So it's important to be aware of the contents. Again, we're not going to go through it because we don't have the time, but perhaps at a later, in another training session, we could if you give me some feedback, we could go into things like this in more detail and step through it. But there's a lot in there. I just commend you to read it. Don't torture yourself over it. Just be aware of what's in there. Like all these things, just know what's in there, and then you'll be aware that if a project comes up, oh yes, I must look at that because that could be relevant. It specifies things like system control for ventilation and air conditioning, fan systems, technical requirements, pump technical requirements, maximum air and water pressure drops. This is an important one when you're doing your static calculations, that the NCC does specify some maximum pressure drops that you're allowed. Okay, we'll have a look at those in a sec. Ductwork and pipework insulation is specified there. Pipe sizing requirements, which is important because they've changed. So like for the energy efficiency requirements, pipe sizes have actually got bigger to reduce the pressure loss in the piping systems. And these things may change again in the 2023 version. So be aware of what's in there at the moment because it's relevant to what you're doing at the moment, but they could change. They might become more stringent. So let's go to section J. I've made a note about the climate zone, so we'll have a look at that when we go there. Page 365. Okay, air conditioning and ventilation systems. Section J is all about energy efficiency for not just for HVAC, but for everything in the building process. Now down here, there's in italics climate zone in section J 5.2. This is important in certain parts of this these clauses because it'll say I'm just trying to see one at the moment, but well, here, for instance, in this table, J52, requirement for an outdoor air economy cycle, depending on the climate zone, it tells you at what point you need to provide an economy cycle. Okay? So depending on the total airflow rate, we're in Melbourne, you're in climate zone 6, so it's anything from 2,000 above, you need to have an economy cycle. If you've got an air handling unit that delivers 2,001 litres a second or 2,000 litres a second, you need an economy cycle, unless it is excluded for some reason. You have to read through and see if there's exclusions there. And the climate zones, if you click on this link here, shows you a map of Australia and then gives you a list of different towns and cities around the country and what their climate zone is. So if you go to, as I said, go to Melbourne, climate zone 6. Out in the west, it's 7, and so on. Warrnambool is 6. So mainly 6 and 7. Swan Hill is 4. So that's an arid climate up there. And these colour codes, it's a little bit hard to distinguish where the boundaries are at times, but there's a legend there that tells you what zone they are, if it's not listed in this table. Sorry, we'll go back to, we'll just quickly run through some of the things in section J. Just bear with me a second. Right, so air conditioning system control, lots of requirements, not too horrendous, but again, you can see here reference to the class of the building. Just look through that and see what you have to do. Then mechanical ventilation system control. Again, climate zone, outdoor airflow rate. What do you need to do? Exhaust systems, car park exhaust systems, time switches, fan systems, lots of requirements there. Generally, the fan suppliers will let you know whether their fans comply with the NCC when you're looking at the selection, but be aware that there are requirements there. Now we get into ductwork. This tells you the maximum pressure drop that you're allowed when sizing ductwork. There are exceptions depending on the type of system that it is. Flexible ductwork must not be more than 6 metres in length, etc. And maximum coil pressure drops, maximum filter pressure drops, maximum clean filter pressure drops. So you need to comply with this, and you can use that in your calculations, but then you need to select a filter that will comply with that. Pressure drops for intake louvers. It's another subject we can talk at length about, and we'll get into that a bit later in the sessions, and so on. Then you've got ductwork insulation requirements, ductwork sealing, pump systems, pipe sizing. It gives you, for the various sizes, the maximum pressure drop allowable, depending on the operating hours per annum, and depending on the type of system it is. Maximum pipe pressure drop for a distributive variable speed system. There's different types of systems, different requirements. And pipework insulation, space heating, refrigerant chillers, unitary air conditioning equipment. Most of the DX split systems and package systems that you'll deal with will comply with MEPS, which is necessary, and gives you some concessions on the ductwork insulation. And then heat rejection equipment. So there's a lot in there. Again, you're not going to memorise it, but have a read through, be aware of it, and make sure that you comply when you're doing your design. So now I want to just quickly go through the Australian standards that are most important to what we do. Firstly, 1668 Part 1 sets out requirements for design, construction, installation, commissioning and operation of mechanical smoke control systems for building classifications 2 to 9, where required by the NCC. And as I said before, also refer to the project fire engineering report, because that might change the requirements of the NCC, and they're allowed to do that. So provided they comply in other ways. So it's a performance requirement. So the fire engineer has a fair bit of say in the project, and will work closely with the building surveyor or certifier in getting any changes the NCC approved for the project. So if the fire engineer or the FER says you need to do something, then you need to do it. It doesn't say you can't talk to them and try and try and change the FER if you want to. If the fire engineer agrees with your argument, then he can change, or he or she can change the FER, but you'd have to have a convincing argument. But it's been done. I've been involved in those processes, and you know, if you've got a logical argument for why you don't need to do what they've asked for, it's worth trying. So for each project,
I have a question for you. If we have working on the DNC project, right? And if we have a FER, fire engineering report, and still we need to refer for the fire and smoke strategy from the 1668.1, or just the fire engineering report enough? Or still we need to.
You have to refer to the NCC and AS1668 Part 1, definitely.
For smoke and fire and smoke control strategies.
Yeah, if the FER doesn't say anything, that means that you just comply with the normal documents. It's deemed to satisfy. So you have to refer to the NCC and AS1668 and comply with what they're asking for that building.
Okay,
The-
so
the
still we need to
FER
refer the 1668.1, right? Both things
Definitely.
need to be referred.
Yes,
Okay.
always. But the FER might give you concessions. That's all. It might change something. So if the NCC says that you must have a pressurization system, for instance, so it's a multi-story building, and look, this is just off the top of my head. It's not necessarily going to happen, but it says you've got to have a pressurization system, zone pressurization. The fire engineer might say, well, actually, we don't need to do that because we've done something else. We've provided some other level. For instance, they might have put sprinklers in the building. They didn't have to put sprinklers in, but they're going to put sprinklers in, and by doing that, we don't need the zone pressurization. Now, don't quote me on that because that's just, that's just an example.
Yep.
But otherwise, you still have to satisfy the requirements of the
Requirements.
NCC. Yeah. Yep. If the FER doesn't say anything, doesn't mean you don't have to do anything.
No,
gotta,
it makes sense now. So both needs to be referred, yes. As a DNC
yes.
contractor, we need to make sure we comply with the say 1668.1 and 2. So
Yeah,
we can't fully
definitely.
rely on the fire engineering report. Yeah.
No, you can
No,
do
that's
what they're
answer.
asked. If it changes something, you can do what they've asked to change. But they also might ask for something that's not in the NCC or AS1668.
Yeah, where we
Okay,
can do the argument.
then you'll have to do it. So each job's different and needs to be treated on its merits. Okay, so I've said we need to determine the building classification and physical characteristics and then determine whether smoke control is required by the NCC. If it is required, NCC in 1668 Part 1 will then specify the requirements of the control system. Now, if we have a quick look at 1668 Part 1, there's lots of tables and diagrams. So just looking at the sections, general requirements, fire protection of openings, smoke control systems general, miscellaneous requirements, kitchen exhaust hood systems, shutdown systems, zone pressurization systems. So when we're getting into this is the NCC is referring to, it's a shutdown system or it's a zone pressurization system. A hot layer smoke control system usually applies to a large shopping centre, for instance. And then the NCC has, when you go through those tables we looked at before, table 2A and 22B, 22B in particular talks about systems that require, or buildings that require a hot layer smoke control system. And the NCC has all those technical details as well. And you'll find that they're very similar to what's in AS1668 Part 1. So you need to look at both and comply with that. I think if you walk into if you're like a typical HVAC engineer, you walk into a shopping centre and you're looking at the ceiling, or any building, you're looking at the ceiling. What's up there? You'll often see, a Woolworths or a Coles or a Kmart, one of those big stores. You'll see a bunch of grills in the ceiling. That's usually a smoke exhaust system, and it's a hot layer smoke exhaust system. So there's a fan, some ductwork and a fan directly above that. And if you park in the car park on the roof, you might even see the enclosure where the fan is. So there's an exhaust fan up there, which in the event of a fire, it's exhausting straight out from the ceiling. That's a hot layer smoke control system. Protection of fire isolated exits, stair pressurization, escape passageways, etc. Air purge systems, not used very often, but it's another option. Generally in a multi-storey building, you'd see a zone pressurization, but you can use air purge. The difference is the large air quantities required in the air purge system. So you don't see them very often. And so on. So I won't go through that in detail because there's too much in there, and you can have a look What I will do is just go to say, just as an example, go to the end of section 8, the zone pressurisation systems. So if we go to page 88, I'll just scroll through. There's some tables there that tell you how the operational requirements of things that start, stop, open, close, dampers and fans and so on. But there's a number of diagrams at the end of most of these sections. And this can be quite helpful if you're looking at a building, say this one here, that is a multi-storey building. What do we need to do for this building, for a zone pressurisation system? You can have a look at that in your spare time, but it's when you read it, it's quite straightforward. But it's just helpful to get an idea of what facilities you need in the building to comply. So each of these sections, I mean, we could spend several hours going through it, and we don't have that time. I'm just trying to give you an awareness of what you need to look at and what's in these documents. AS1668 Part 2, mechanical ventilation, sets out the requirements and guidelines for determining ventilation rates for general application in buildings. In particular, minimum outside air and exhaust requirements are provided, including some guidelines for healthcare functions. If you do a hospital, there are codes, separate codes for hospitals, which set out the mechanical ventilation requirements in each state. They tend to be a little bit different. So don't just rely on AS1668. You need to look at the hospital codes as well. Part 2 is for mechanical ventilation. Part 4 is for natural ventilation. So I'll just keep reading through. It doesn't provide ventilations for some specialised processes or industrial processes such as woodworking and laboratories. Ventilation for these special projects are found in other standards and references beyond the scope of what we're talking about here. But I am mentioning here a code that's really useful. I've been involved in some projects, for instance, a woodworking factory or in a TAFE college with woodworking, metalworking, things like that. It's not really covered by AS1668, but there's a ventilation, industrial ventilation code that's really helpful. And I've given you a link to the website there. I've actually got it here. It's been around for decades. It was updated in 1998. I don't know if it's been updated since then, but you can download this for free. And if you look at the index, you know, there's a heap of stuff in there that's really useful if you've got a special job that needs some industrial ventilation. So we'll just go to page 61. I'm sure you're probably familiar with these, so I'm not going to spend too much time on it, but these tables, I'm sure you've seen these. These set out outside air ventilation rates for different types of situations and buildings. If you don't know the number of people, it gives you a net floor area per person, so you can work out the occupancy and then the outside air rate per person or for whatever it may be. If you do know the number of people, if they specifically say that there's 100 people in this space, then use that. You have to use that. If they don't, you might, like a bar, for instance, if they say we're only allowed to have 100 people in the bar, but if you look at the table, it might say, well, it's 1 person per square metre. And you might finish up with 300 people, which is like you were talking about before, Kaushik. But
yep.
Yeah, you want to have the right number of people, because you're going to your heat load's going to go up accordingly. All right, and there's for bathrooms, for instance, what are we? Lost it there. For hotels, motels, resorts, I was just looking for bathroom. sorry, I'm in the wrong table. We'll come to that in a minute. For exhaust rates in bathrooms is what I was going to talk about. We'll talk about that in a second. We'll go on to that. So the next table, Appendix B, is for exhaust ventilation rates. So once again, for different types of areas, it gives you a rate, which might be litres per second per square metre, for what might be in air changes per hour. And for bathrooms, we've made some amendments to our standards here. We like to use a bit more than the standards, but you don't have to. But we've just found that we like to use 50 for a shower and 35 for toilets. But basically, you can use 10 litres a second per square metre of floor area of a toilet area, or 25 litres a second per fixture. And if you've got, say, a domestic bathroom, you can have 25 litres a second per room, which might have a bath, a shower, and a toilet. And so that's if you follow the code, you've done the right thing, but you might want to increase it if you think it needs a bit more. Good, mate. Just need to have a bit of a drink. I want to point out some of the things that we consider often and are very important. Exhaust air discharges in section 310. So page 38 talks about enclosures that may be served by a common exhaust system. So let's have a look at that. Page 38. Okay, I don't know if you're familiar with this table, but this is an important one. This is talking about where you can combine exhaust systems, okay? So you can have from a bathroom or a toilet or there's any of those things there can be combined into a common exhaust system, but you can't combine a toilet with some other general ventilation system because you might get the back feed from one to the other. So that's an important one. There's a table here, objectionable effluent discharges. This is talking about kitchen exhaust or industrial exhaust compared with discharges not deemed objectionable. So that's a good one to have a look through because that will come up again and again. Table 3.4, separation distances from discharge to intakes. Every job will have this. You might have outside air intakes and exhaust discharge points. And it gives you the distance of separation required. So if it's less than 200 litres a second, it's 1 metre, but just refer to the note. If it's greater than or equal to 1,000 litres a second, it's got to be 6 metres. So be aware of those that like in a residential apartment, for instance, you can have your intakes and exhaust or your windows and your exhausts close to each other within reason. They don't have to be 6 metres apart. Outdoor air intakes. Now this is important. What's an acceptable place to bring in outside air? So on page 16, we can have a quick look at that if you like. I'm just conscious of the time. I know you've all got other things you've got to do. Outdoor air intakes location shall be located and arranged so that under all conditions of normal operation, contamination from exhausts, is not going to affect it, or the effects of wind and adjacent structures and other factors do not cause the flow rate to be reduced. Have a read through that, because this comes up again and again. What's an acceptable place for an outdoor air intake? Okay. And replenishment of exhaust air. Page 35. Sorry, let's go back to here. Page 35. This is another one to have a look at. So when you're exhausting air, the makeup air has got to come from somewhere. Okay, so You've always got to try and provide an air balance in the building. If you've got exhaust going out, where's the makeup coming from? If it's a toilet exhaust, it might be drawing the excess outside air from the occupied space to provide the exhaust makeup. If it's a kitchen, you might have to have a separate outside air supply to the kitchen. Plus, you might have some makeup from adjacent areas. So be familiar with that. Okay, I just mentioned there are some do's and don'ts in that section that you need to be aware of. 1668 Part 4. This talks about natural ventilation. This goes into a bit more detail than the NCC, but for natural ventilation of, say, a residential building or in simple cases, the NCC requirements are covered in this standard anyway. This goes into a bit more detail for if you're thinking about an ESD solution to naturally ventilate a building rather than air condition it. That has been quite popular for reducing energy consumption and saving capital cost on air conditioning plant. And it also provides details for natural ventilation of car parks, which is an option that's quite useful if the car park's above ground. It's quite detailed, but if you work through it, there's certainly savings to be made in mechanical ventilation systems. So it's worth considering, and I won't go through that code because we're just about out of time. So just to finish off, a full understanding of the requirements of the NCC and the AS1668 codes takes time. And look, you know, if I'm working on a project, I need to refer to it. I've been working in it for 40 years and I don't know everything that's in there. I've got an awareness though. I know what I need to look for, and so you don't get caught. If you don't comply, you know, you're going to be in trouble. So you need to know what's in there and make sure that you apply it to the projects you're working on. As I said, it's a far stretch to expect that the contents can be memorised. If you can memorise that, you're a genius. There is, as I said, insufficient time in this program to study it in detail and analyse project requirements on a case-by-case basis. Excuse me. These standards will be updated from time to time. The current editions of AS1668 are referenced in the NCC 2019, as I said at the start. So, look, I know it's been a bit of a rush through this, but it's just, you need to just assess each project as it comes up. And even if you just flip through the index and through the sections of these standards and NCC, just be aware of what's in there and never forget to refer to them. That's the important thing. Okay, any questions before we wrap up? All good?
All good.
Okay, well, I hope it's been helpful. There'll be another session next Tuesday, so I'll send you out the notes for that and
Yep.
and an invitation for the time. It'll be the same time next Tuesday. And I sent out yesterday an update to the schedule. I hope you received that. I've had to make a change in May because I've got a wedding coming up. My youngest daughter's getting married, so I decided I better take that week off and go see if I can be useful. So I had to put that back a week, but that other things might come up as well. So I'll let you know if it changes. Otherwise, you can sort of plan forward for when those dates are on. Okay.
Thank
Thank
you.
you. Thanks for your attendance.